This video is about being able to differentiate e to the x and e to the kx. So e is equal to Euler's constant is equal to 2.71828. Does go on forever, but to 5 decimal places. So it's called Euler's constant. So it's a mathematical constant, so it's a number, so it's not an unknown. And also it's an irrational number, so it cannot be expressed as a fraction. And there are no patterns in the decimal places. So we need to be able to differentiate y. If y is equal to e to the x, so that's 2.71828 to the power of x, what is f dash of x? And if y is equal to e to the x, is similar to saying what is dy dx. So let's investigate that using the graph of e to the x. So this black curve here is y is equal to e to the x. And if I draw a tangent at the point x equals 0, you can see y is equal to 1, obviously, but also the gradient is equal to 1. And if I change this point P, you can see the y value is, when the y value is 2.3, the gradient is 2.23, so on. So basically, the gradient is always equal to the y value. Now, if we plot the gradient function, look at the gradient function. What does it look like? It looks like it is the same thing as y is equal to e to the x. So what you need to know is when you differentiate y is equal to e to the x, you still get e to the x. So if y is equal to e to the x, f dash of x is equal to e to the x. And if y is equal to e to the x, dy dx is also equal to e to the x. So that's the key thing to take away. The derivative of e to the x is equal to e to the x. Okay, so let's look at some questions where we have to use the chain rule to differentiate functions involving e to the x. Okay, so differentiate the following. First is e to the 2x. So let u be equal to 2x. And then y is equal to e to the u. Du dx would then be 2. And dy du, e to the u differentiates to e to the u. Then dy dx, according to a chain rule, is dy du times du dx, which is equal to e to the u times 2, which is 2 e to the u, which is equal to 2 e to the 2x. Okay, question 2. So here, let's make, so there we made the inner function 2 to the x for the chain rule. Here we'll make the inner function 3 minus x. So let u be equal to 3 minus x. Then y is equal to 9 e to the u. Du dx would be equal to minus 1. And dy du will be equal to 9 e to the u differentiates to 9 e to the u. Then dy dx will be equal to dy du times du dx, which is equal to 9 e to the u times minus 1, which is equal to minus 9 e to the u, which is equal to minus 9 e to the 3 minus x. Your last example, y is equal to 4 e to the root x over e to the x. Now that is the same thing as writing 4 e to the x to the power of a half divided by e to the power of x. Using the laws of indices, this is the same thing as 4 e to the x to the power of a half minus x. And then we're differentiating this. So let u be equal to the inner function, which is x to the power of a half minus x. So x to the power of a half minus x. And then y will be equal to 4 e to the u. Dy du sorry, not dy du, because u is written in terms of x, will be du dx. Du dx is equal to half x to the minus a half, take away 1. And dy du will be equal to 4 e to the u, because e to the u differentiates to e to the u. Then dy dx is equal to dy du times du dx, which is equal to 4 e to the u times du dx. Okay, classic mistakes, people don't put a bracket around it. Make sure you put a bracket around it, or else you'll just have the minus 1 not multiplying by 4 eu. To put a bracket around the two separate things if you need to. And if you want to rewrite that, that will be the same thing as 4 times half x to the power of minus a half, take away 1, e to the u, and u was x to the power of a half minus x. So that would be the answer. The next question, use the chain rule to differentiate each of the following functions. Okay, 1. Y is equal to e to the x squared, which is the same thing using laws of indices as e to the x times 2, which is equal to e to the 2x. Now dy dx, okay, we're going to use mental skills to do this. So e to the 2x differentiates to e to the 2x, and from the inner function, when you differentiate it, you get 2, so it's going to be times by 2, which means 2 e to the 2x is the answer. Okay, so this is the informal chain rule in your head. Question 2, y is equal to e to the 4x over 2 e to the 2x, which is equal to half e to the 4x take away 2x, because using the laws of indices, which gives me half e to the 2x. So now I need to differentiate informally using the chain rule. So e to the half, we've got e to the 2x, which differentiates to e to the 2x. The inner function is 2, so 2x, so when we differentiate, we get 2. When we simplify this, we get e to the 2x. Question 3. Y is equal to 2 over root of e to the x. This is the same thing as 2 over e to the x to the power of a half, which is the same thing as 2 over e to the power of half x, which is the same thing as 2 e to the power of minus half x. Now you need to differentiate it informally using chain rule. So you've got 2 e to the minus half x goes differentiates to e to the minus half x. Minus a half x, which is the inner function, differentiates to minus a half. So you end up getting minus e to the minus a half x, which is equal to minus 1 over e to the half x, which is equal to minus 1 over root of e to the x. So that would be your final answer. Question 4. Y is equal to 2 times root e to the x, which is equal to 2 times e to the x to the power of a half, which is equal to 2 e to the half x. So now you need to differentiate it informally. So you get 2 e to the half x. E to the half x differentiates to e to the half x, and then half x differentiates to half. So you end up getting e to the half x, which is equal to ex square rooted. Question 5. Y is equal to e to the x divided by root e to the x, which is equal to e to the x over e to the half x, which is equal to e to the x take away a half x, which is equal to e to the half x. Now we differentiate this, so dy dx is equal to e to the half x from the inner function, which is half x. When you differentiate it, you get half, which is equal to half e to the half x, which is equal to half root of e to the x. Question 6. Y is y is equal to 1 over e to the 2x is equal to e to the minus 2x. So when you differentiate this, e to the minus 2x differentiates to e to the minus 2x. The inner function of minus 2x differentiates to give you minus 2. So you get minus 2 e to the minus 2x, which is equal to minus 2 over e to the 2x. Okay, question 7. Y is equal to 2 over e to the x, which is equal to 2 e to the minus x. So when you differentiate this, 2 e to the minus x differentiates to 2 e to the minus x. And from the inner function, which is minus x, you differentiate to get minus 1, which gives you minus 2 e to the minus x, which is equal to minus 2 over e to the x. 8. Y is equal to square root of e to the 2x is equal to e to the 2x to the power of a half, which is equal to e to the 2x times half, which is e to the x. And when you differentiate e to the x, so you get e to the x. Differentiate the following with respect to x. Okay, so again, change rule informally. So 5 e to the 0.4x, so 5 stays there. That's right. Y is equal to 5 e to the 0.4x. So dy dx will be, the 5 stays there, e to the 0.4x becomes, differentiates to e to the 0.4x. The inner function of 0.4x differentiates to 0.4. 5 times 0.4 is equal to 2. So you get 2 e to the 0.4x. Y is equal to e to the 3x plus 2 e to the x. Dy dx is, you differentiate each one separately. E to the 3x differentiates to e to the 3x. And then from the inner function of 3x, you get 3. Plus 2 e to the x differentiates to 2 to the x, because the inner function of x differentiates to 1. So if you want to write 1, you can, or you just leave it as 2 e to the x. So when you simplify, you get 3 e to the 3x plus 2 e to the x. Okay, the last one, y is equal to e to the x times e to the x plus 1, which is the same thing as e to the x squared plus e to the x, which is the same thing using laws of indices as e to the 2x plus e to the x. So when you differentiate this, e to the 2x differentiates to e to the 2x times 2 from the inner function, plus e to the x differentiates to e to the x. So you get 2 e to the 2x plus e to the x. Okay, find the gradient of the curve with the equation y is equal to e to the 3x at the point where ax equals 2, bx equals 0, and cx equals negative 0.5. So we know that y is equal to e to the 3x. So when you differentiate this, dy dx will be equal to e to the 3x times by the derivative of the inner function, which is 3. So you end up getting 3 e to the 3x. So for part A, if you want to find the gradient at the point x equals 2, then you need to substitute x equals 2 into the gradient function, which means you get 3 e to the 3 times 2, which is equal to 3 e to the 6. For B, if you want to find the gradient at the point x equals 0, then you need to substitute x equals 0 into the gradient function, which means you get 3 e to the 3 times 0, which is equal to 3 e to the 0. E to the 0 is 1, so it's just equal to 3. C is you want to find the gradient at the point x equals negative 0.5, which means you need to substitute negative 0.5 into dy dx, which means you get 3 e to the 3 times negative 0.5, which is equal to 3 e to the minus 1.5 as an exact answer. The function f is defined as f of x is equal to e to 0.2x, x is the element of reals. Show that the tangent to the curve at the point 5e goes through the origin. Okay, so we have f of x is equal to e to the 0.2x. So that means f dash of x will be equal to e to the 0.2x times by the derivative of the inner function, which is 0.2. which is equal to 0.2 e to the 0.2x. Okay, so we need to find the gradient. Gradient at 5e is the same thing as f dashed, substituting into the gradient function the x value, which is 5, which is f dash of 5, which is equal to 0.2 e to the 0.2 times 5, which is 0.2 times e to the 1, which can be written at 0.2e. Okay, next we need to do is now we have, because we know we have a point that it goes through and a gradient, so using y minus y1 is equal to m times x minus x1, then we end up getting y minus e is equal to 0.2e times x minus 5. If we expand this, we get y minus e is equal to 0.2ex minus e, which means we can cancel out the minus e's, which means we get y is equal to 0.2ex. Therefore, equation is of the form y equals mx with no constant c. Therefore, the tangent has y-intercept. So c is equal to 0, y-intercept equal to 0, and therefore goes through origin. Okay, if curve C has equation y is equal to e to the 4x minus 5x, find the equation of the tangent to C that is parallel to the line y equals 3x plus 4. If it's parallel to the line, y equals 3x plus 4 implies the gradient is equal to 3. So the gradient there is equal to 3. Okay, so if we have y is equal to e to the 4x minus 5x, then dy dx will be equal to e to the 4x times the derivative of the inner function, which is 4, minus 5x differentiated gives you 5, which is equal to 4 e to the 4x minus 5. So that means the gradient, because m is equal to 3, dy dx must be equal to 3. So m equals 3 implies dy dx must be equal to 3, which implies 4 e to the 4x minus 5 is equal to 3, which means 4 e to the 4x is equal to 8, e to the 4x is equal to 2, which means 4x is equal to ln 2, which means x is equal to a quarter ln 2. So if we know what x is equal to, we can always find out what y is equal to. So this implies y will be equal to e to the 4 times a quarter ln 2 minus 5 times a quarter ln 2, which simplifies to the 4 and the quarter cancel out, e and ln cancel out, so you're left with 2 there. So the 4 and the quarter cancel out, e and the ln cancel out, so all we're left with is 2 minus this second term simplifies to 5/4 ln 2. So now, using y minus y1 is equal to m times x minus x1. We get y minus 2 minus 5 over 4 ln 2 is equal to m, which is 3, times x minus a quarter ln 2. If we expand this, you get y minus 2 plus 5 over 4 ln 2 is equal to 3x minus 3 over 4 ln 2. If you take everything to the right hand side except for y, you get y is equal to 3x plus 2 minus, so minus 3 over 4 minus 5 over 4 gives you minus 8 over 4, which is minus 2 ln 2. So that would be a final answer.